Welcome back to another Algebra 2 video. I'm Mr. Hibble. Today we're looking at a test review about solving linear equations, inequalities, absolute value, and systems. So there's a lot of solving that we're talking about today. Today I just want to get through 6 problems, just reminders about each of these different things. Okay? So looking at these first few, it's just solving an equation and some inequalities to begin. Remember, if you have parentheses, let's just distribute. Let's get rid of those. So make sure you're multiplying to the inside. Remember, the issue that most people have when they go through this process is with the signs. For example, notice this 5 we're distributing is negative, so negative 5 times 2 is negative 10. Distribute your negative again. Negative 5 times negative 8 is positive 40. Oops. Okay, so from there then, combine your like terms. Everything is on the same side of our equal sign when we combine. 12 minus 10 is 2. We can combine these other values as well to give us 34. And once you do those first two steps, this process should be pretty easy from there, right? We just move whatever adds or subtracts first generally. And then you divide by the value out in front of x, and you should get x equals negative 19. The second problem, number 2 over here, similar idea, distribute to get rid of your parentheses. Be careful when you go through this process now, though, because we have an inequality sign. Remember, those less than and greater than symbols, they work the exact same except for one small rule, where that rule states if you multiply or divide by a negative, the sign, the inequality sign, flips. It changes directions. Well, the first thing we're doing is subtracting, so nothing happens to it now. But when I divide by 4, and more specifically negative 4, I am dividing by a negative. Whenever you multiply or divide by a negative, the sign in the middle is going to change directions now and go the other way. We'd end up getting our answer. If you did need to graph that, that'd be an open circle with your arrow going to the right. Would look something like that. Number 3, looking at that one. Again, parentheses, get rid of them, then combine your like terms. 7x minus 3x is 4x. Move the values over. 5 minus 21 is negative 16. And now we're dividing by 4. Be careful on this one. Again, we need to pay attention to our inequality sign. A lot of people want to flip the inequality sign here, but realize the negative with the 16, I don't care about that value. That's the value we had originally. I care about the value I'm moving and whether I'm dividing or multiplying by a negative in that case. Well, right now we're dividing by positive 4, so the inequality sign is actually going to stay the same direction on this one. Let's go ahead. Let's look at number 4 now. On number 4 for this problem, we have absolute value. I like this strategy we've been doing recently where we box in that absolute value, right? Inside that box, you cannot touch anything inside that box. I cannot touch the 2. I cannot do anything with the 3 until everything outside of the box is on the other side of this equation. So just like before, you should move whatever adds or subtracts first. It looks like we're subtracting 8. So let's add it to the other side, giving us 28 now. I still need to get rid of that 4 though, right? So a lot of people, right, they want to multiply to the inside. But now that I have this box around it, it should make it clear that I cannot do that. So instead of multiplying to the inside, I need to move this value. Let's get rid of it instead. So to get rid of it, I would do the opposite of that multiplying. So I would divide by 4 on both sides. And now we've accomplished our goal. The box is by itself. So once you've done that, once you have the box by itself, the next thing you need to do is you create 2 separate equations. One that is equal to positive 7, one that is equal to negative 7, and you solve both of those. You get 2 separate values in doing this. One value, which is x equals 2. Make sure that's equal to -7 for the second equation. Mine was positive at first. Make sure the second equation is negative. Divide by 2 on both sides, and now I get x equals -5. Those would be your two solutions for number 4. Okay, so strategy there, put a box around the absolute value, move everything from the outside of it. Once that box is by itself, where that arrow is pointing, then you separate to two equations. Remember, absolute value is a measurement of distance. So we're saying the distance from 0 is 7. There's two values that are 7 units from 0, which is +7 and -7, which is what we are showing in our work. Bottom two problems here, solving using elimination or substitution. Use whichever one you like more. Number 5, I will do a substitution. Do you have to do substitution there? No. I'm just going to show one process for each. So I'll do one substitution, one elimination, so that we do have an example of both. If you just want to make sure you know one really well, you might skip to the elimination part and watch that part. If you want to see substitution, keep watching. That's the one we're going to go over first. Substitution, you always need a variable by itself. In the bottom equation, I could get x by itself pretty quickly by moving the y to the other side and give me 5 plus y. Well, let's just say that x was equal to 5. Let's ignore that y for just right now. Well, if x was equal to 5, I could go into the top equation, get rid of that x, and replace it with 5, right? That's what we could do. We've done that a lot throughout our different math classes. But x was not just equal to 5. We said x was equal to 5 plus y. That means I replace x with that entire expression. And now that we've done that, we can go ahead and solve just like we did on the first few. We multiply, we combine like terms, and we solve. (15 plus 5y equals 5). Move whatever adds or subtracts first. Get your variable by itself then, and you'd end up finding that y is equal to -2. Once you have a variable, then you can plug back in just like that substitution step we've already done. Plug into any of the equations that we use. That could be the top one, the one that we changed, or the new one. You could plug into any of those three. Personally, I'm going to plug into the one that we changed because that's where x is actually by itself, which is the variable I am solving for. 5 plus -2 is 3. Now you have your answer, 3, -2, x comma y. Let's look at number 6. Number 6 is elimination, just using a different process for that. Again, you could use the same process that we did on that last problem. Oops, why is that not working? Okay, for some reason it's not letting me circle that. That's okay. So elimination, I'm just going to write it up here so it's not in my way for this process. But on this one, we need to create opposites with elimination. And remember, opposites are the same number, different signs. I saw a lot of people today in class trying to multiply the top equation by 6. But if you did that, you'd have +6x and +6x. Those do not cancel. Those are not opposites. So instead, let's multiply by something that does create opposites. What I notice is I have -2y and 4y. I could make these be opposites, right? They already have different signs. I just need to figure out what to multiply -2 by to give me the opposite of 4. So let's look at what that process is like. In order to do that, what I can do is I can multiply by +2 here, because 2 times -2 would give me -4, which is exactly what I want. Remember, the biggest mistake people make going through this process is when they distribute that value, they forget to multiply to both sides of the equation. That 2 does need to multiply with the 12 as well, giving us 24. The bottom equation we did not change. That one will just come over as 6x plus 4y equals 8. From there, then, go through your elimination process, get rid of the opposites, add your other values. 8x equals 32 then. get the x by itself, we end up finding x is equal to 4. Once you have one value, you can always plug back in to see what the other one is. Use either of the two original equations. Use the new one we made. It doesn't matter. I'm just going to use one of the originals. I like the top original personally, just because there is less values to deal with. Make sure you replace the correct value. We had x, so I'm going to replace x. And then I'm just solving to get my variable by itself. When you do so, you should end up getting y equals -4. So our solution then for -4 would be our final value. Thank you for watching. That is our review for our test tomorrow. Make sure you are prepared for that.